9.4, solving quadratic equations by completing the square. So this is something new. We're going to work on completing the square. All right, what is that? Completing the square is for an expression of the form x squared plus bx, you can add a constant c to the expression so that x squared plus bx plus c is a perfect square trinomial. And if you remember what a perfect square trinomial is, it is the one that would look like this. X squared, let's say, plus 6x plus 9. You could factor this into x plus 3 squared, because if you were to FOIL this, you would end up with your perfect square trinomial. So what we're going to try to do is get an expression where we're only given the x squared plus the 6x, and we want to make it into a perfect square trinomial. To do this, we're going to complete the square, and the first step is to find 1/2 of b, the coefficient of x. So it's not the coefficient in front of x squared, it's the coefficient of b, the one that's being multiplied to just x. Step 2, you're going to square the results of step 1. And finally, step 3, we're going to add the results from step 2 to x squared plus bx. Okay, so let's try one of those examples. Completing the square. So we have x squared plus 6x, which we already know is going to be plus 9 because I already wrote it above, but now let's teach you how to do that. So you're going to take the coefficient b, so that's the one being multiplied to only x. So that is, in this particular example, 6. So we are going to take 6, we are going to divide by 2, and then you're going to square it. So we're going to have 6 divided by 2, which is 3, and square that. That equals 9. So to complete the square, we would add 9. And so your final answer would be x squared plus 6x plus 9. It then tells you in the direction you are going to factor the trinomial. So if we're going to factor this, I know a lot of people like to skip steps because they can divide by 2 in their head and square it in their head. But if you write it out, whatever you get right here, that's actually your answer. So positive 3. So when you go to factor it, that number, whatever's here, after you divide by 2, that's what your factor is going to be. So let's try with a new equation. I would actually like to do an easier equation than b first. So let's add x squared minus 16x. So something new does come up. Our b coefficient is actually negative 16, not positive 16. So we're going to take that sign with us. So we're going to take negative 16 divided by 2 and square it. So negative 16 divided by 2 is negative 8, and I wouldn't skip this step. And then when you square it, you end up getting positive 64, because a negative times a negative is a positive. So we would have to add 64 to the x squared minus 16x to make it a perfect square. So to be a perfect square trinomial, we have x squared minus 16x plus 64. That's the first part of the directions. Now the second part said to factor the trinomial. So in order to factor it, like I said, don't skip this middle step because the minus 8 is actually it's how it gets factored. So we have x minus 8 squared, and that is your trinomial factored. Let's go to b. This one, because your b coefficient is odd, okay, we have negative 9 divided by 2 and squared. The middle step that I say don't skip, I wouldn't put it as a decimal as negative 4.5. I would just keep it as negative 9/2. This, in this case, is actually the part that you use when you factor. So let's first square it. negative 9 times negative 9 is 81. 2 times 2 is 4. So we're going to add 81 over 4 to make it a perfect square trinomial. So we have x squared minus 9x plus 81 fourths. Now when we factor it, we're going to have x and we're going to have a square. What we put in the middle would be the negative 9 halves. So it'll read x minus 9 halves squared. Okay, so we can actually use completing the square to solve a quadratic equation. So you are used to factoring, but we're going to do it differently this time. So if we have x squared minus 16x equals negative 15, we are just going to look at the left side of the equation at first, and we're going to say, all right, let's complete the square by taking the b term and dividing it by 2 and then squaring it. So negative 16 divided by 2, and then we'll square it. So we get negative 8 squared, which is 64. So this 64, we can add it to x squared minus 16x plus that 64. But here's the deal. If we add something to one side of the equation, in order to keep the equation true, we have to add that same thing to the other side. So I'm going to add 64 to the left, but then I must add it to the right. And just to prove this too, let's make it really simple. Let's do 2 plus 3 equals 5. Well, yes, that's true. Now, if I were to add, let's just say 4. If I add 4, 2 plus 3 plus 4 is not equal to 5. But if I add 4 to both sides, well then 2 plus 3 plus 4 is also equal to 5 plus 4, and your equation stays true. So if I add something to the left of the equal sign, I have to do it to the right. Now, you know how to factor x squared minus 16x plus 64. It's a perfect square trinomial. So I know that this factors into x, and you can use the shortcut I taught you. It's that one. It's x minus 8 squared equals negative 15 plus 64, and we end up with 49. Now from here, in order to get rid of the square, we're going to take the square root. And since this side had the square, this side we will take the square root, but we will take plus or minus that square root. So let's rewrite it as x minus 8 equals plus or minus the square root of 49, 7. So now I'm almost there. I have to solve, but I have two equations because I have one equation as x minus 8 equals positive 7 and x minus 8 equals negative 7. So if I add add 8 to both sides, I get x equals 15 in this situation. And over here, if I add 8 to both sides, I get x equals 1. So those are your two solutions for that example. Okay, for example 3, it has solving a quadratic equation in the form of ax squared plus bx plus c equals 0. So in this situation, the example is actually on the next page. You have 2x squared plus 20x minus 8 equals 0. All right, so let's rewrite that. 2x squared plus 20x minus 8 equals 0. Instead of trying to factor this, we are going to complete the squares. You couldn't even factor it because it doesn't turn out to be nice, clean integers. So let's complete the square. But before you can do either this, the first step or second step in this particular one, but you're going to add 8 to both sides. So then we have 2x squared plus 20x equals 8 because it goes away on the left. Each of these terms are divisible by 2, so I'm going to divide this whole thing by 2. And I'm going to get x squared plus 10x equals 4. Okay, now let's move over here to the right. And let's complete the square by using the rule that we just learned. We take the b term, which would be 10, because it's being multiplied to x. That's the b coefficient. We're going to take 10 divided by 2 and square it. So 10 divided by 2 is 5. 5 squared is 25. Then from there, we will add the 25 to both sides of the equation. So we have x squared plus 10x, and we'll add the 25 here, equals 4. But since we added the 25 to the left side, we'll have to add it to this right side. Now, x squared plus 10x plus 25, we need to factor that, and that would be x plus 5. We have the 5 here, and we square it, equals 4 plus 25 is 29. So one thing that I haven't mentioned, just because you guys already know how to factor this, but realize we need the number that when you multiply, you get 25, and when you add it, you get 10. So when we were to FOIL this, 5 times 5 is 25, 5 plus 5 is 10. So now I need to get the x alone, and in order to do that, I first have to take the square root of both sides. So for this one, the square root cancels the square, and I get x plus 5 equals, and since this side had a square, we actually have to take plus or minus the square root of 29. All right, so now we have two different equations since we have plus or minus the square root of 29. We have x plus 5 equals positive root 29, and I have x plus 5 equals negative root 29. So here when I subtract 5, because one has a square root sign and one doesn't, you're going to keep your constant in front, negative 5, plus the square root of 29, and they are not like terms, so we call it quits on that answer. That's all we can do. Now subtract 5 from this side, as well as the right side, and we get x is equal to negative 5 minus root 29. And those are your two final answers. For the next one, you're going to do it on your own. You're going to stop the video, complete the square for solving this quadratic, and then check your answer. Okay, so your final answer should have been negative 6 plus 2 root 7 and negative 6 minus 2 root 7. You could technically answer this as negative 6 plus or minus 2 root 7. That's okay as well. So m equals. Okay, for the next one, example 4, we have finding a minimum value. So we know that it's a minimum value because when you look at this quadratic and this function, y equals x squared plus 4x plus minus 1, you have a positive coefficient in front of x squared, which is just 1 since there's no number. So that means that our parabola will open up. So we'll have a minimum value that we need to find. Okay, so in order to do this, we're going to write this in vertex form by completing the square. So let's move the constant to the other side of the equation. So we have y equals x squared plus 4x minus 1. The constant is 1, so we're going to add 1 and bring it over to the other side. So now we have y plus 1 equals x squared plus 4x. Now we're going to complete the square, so we need to take the b coefficient in front of x, and we're going to divide it by 2 and square it. 4 divided by 2 squared. 4 divided by 2 is 2. When we square 2, we end up with 4. So we're going to be adding that 4 to both sides of the equation. So let's complete the square. X squared plus 4x plus the 4 completes that square. But you know the rule, if we add something to one side of the equation, we must add the same thing to the other side. So we have y plus 1 plus the 4. Now let's simplify this whole equation. We have y plus 1 plus 4, so that's y plus 5. equals, let's factor this side. So what times what gives you 2, and when added together gives you, what times what gives you 4, and when you add it together you get 4, and the answer is 2. So x plus 2 squared, or the shortcut, whatever this number is, that goes right here. Okay, so we're almost in vertex form. The last step we have to do is subtract the 5. And now let's rewrite the final equation. Y equals x plus 2 squared minus 5. Now that is your equation in vertex form. And remember, vertex form gives you your vertex in the equation. The vertex form is y equals a parentheses x minus h squared plus k, where the vertex, little review here, would be hk. So for our equation, y equals parentheses x plus 2 in parentheses squared minus 5, our vertex would be negative 2, negative 5. And the minimum value is what the y coordinate is. So it would be negative 5. So in our parabola, it would open up, and on the y-axis, negative 5 would be the lowest number where the graph hits. Okay, for the next example, we have a parabola that has a negative x squared, which means it's going to open down. So we'll have a maximum height on the y-axis. So let's find that by writing it in vertex form by completing the square. So we have y equals negative x squared, and that negative is going to make us do an extra step. So negative x squared plus 2x plus 7. Okay, so first let's get the constant to the other side, so we can set the equation up to complete the square. So we have y minus 7 is equal to negative x squared plus 2x. So before I take the b coefficient, divide it by 2, and square it, I'm going to factor out the negative sign in front of the x squared. So I want x squared, and since I took out the negative, this will turn into minus 2x. All right, I want to complete the square, I need my coefficient in front of the x squared to be positive. So now let's take the b coefficient, and we've changed it to negative 2. So we end up with negative 2 divided by 2 squared. So that would be negative 1 squared, which equals 1. So this part's a little bit tricky, so please pay attention. We need to add this 1 into this part of the equation to complete the square. So let's do that. We have x squared minus 2x plus 1. Now that is in parentheses, and we are going to drop down the negative sign. So essentially, when you look at this side of the equation, if you distribute this negative sign to everything inside the parentheses, you actually, and I'll write it over here, have negative x squared plus 2x minus 1. So we actually added negative 1 to this side of the equation. So we have to add this negative 1 to this side of the equation. So let's write y minus 7 minus 1. Now let's simplify the equation, and we have y minus 8 equals negative, and this part, let's factor x squared minus 2x plus 1. So what times what gives you positive 1, but when you add it together you get negative 2, and the answer would be negative 1. So we have x minus 1 squared. And we're almost done writing our equation in vertex form. We're going to add 8 to both sides. And our final equation would be y equals negative x minus 1 squared plus 8. So the negative sign tells us that, it opens down. This tells us that in our vertex, the x would be positive 1, and then the plus 8 tells us that our y value would be 8 in our vertex. So that's your vertex. And to get the maximum point, we really just care about the y value, and that would be your max would equal a value of 8 on the y-axis. Okay, the last example, example 6, asks, which of the functions could be represented by the graph and explain? So we need to just go through our rules here. So the first thing, let's look at the function f of x equals negative 1/2 parentheses x plus 4 squared plus 8. So from this equation, we can tell a couple things. If this was representative of this graph, the negative 1/2, so this is vertex form, the negative 1/2 tells you that it opens down. So I'm going to write opens down, which is good because this graph opens down. And then from this graph, we can also tell that the vertex would be what? Because remember, it's x minus h squared plus k. This is the a value, the negative 1/2. So this would be x minus negative 4. So your vertex would be negative 4, 8. When you look at this graph, negative 4 would actually go to the left and then up 8. So our vertex would be over here. So does this represent f of x? And the answer is no, because the vertex is not in the right spot. All right, so f of x is out. Now let's try g of x. All right, in this equation, we have a negative 1 for our a, so that means it opens down, which is good because our graph does open down. We have a vertex of 5, 9. And we know this because this follows the formula x minus h squared plus k. And of course, the a value is in front, negative. So h would be 5, k would be 9. And that would work if you look at the graph. We don't know the exact numbers, but 5, 9 would be over the right 5, up 9. So that's possible. All right, so g of x is a possibility. So let's write that g of x could be a possible representation of the graph. And then let's look at m of x. So m of x is represented by this equation. And when I look at this equation, the first thing I think of is, okay, if I were to solve this and I had 0 in the y spot, I would have 2 x values of 3 and 12. And when I look at the graph, I'm like, oh, this could be 3 and 12, so that's possible. My next thought is I would look at this, and if I ended up foiling this to rewrite the equation differently, I would get m of x equals x squared, because x times x is x squared, you'd have minus 12x minus 3x. So then you'd have minus 15x, and then negative 3 times negative 6 would be positive 36. So the reason why I did this is because when I look at x squared, it's positive. It has a positive 1. So that means that the graph will open up. Does this graph open up? No. Therefore, we can eliminate m of x. And we can write no because the graph doesn't open up. All right, last one. Let's see if p of x could be a representation of this graph. So we have p of x equals negative x minus 2 in parentheses times x minus 8. Okay, so I don't even need to FOIL it, but if I did FOIL it, I would get, and I'm going to write it down here, p of x is equal to negative parentheses x squared, and then you have x times x is x squared, x times negative 8 is negative 8x, and negative 2 and negative x is negative 2x, so you add those together, get negative 10x, and then negative 2 times negative 8, you get a positive 16. Then, when we take the negative sign and distribute it, you end up with negative x squared plus 10x minus 16. And I just did all that just to show you that the coefficient in front of x squared is negative. So that means that our graph is going to open down. And that's a good thing because it does open down. Now the other thing that I would do is think about if I were to put 0 into y's spot because it's set up where it's already factored. Well, 0 equal to x minus 2. I would get x is equal to positive 2. And here 0 equal to x minus 8. I would get x equals positive 8. And I could look at this graph and say, hey, this could be 2 and this could potentially be 8. So my conclusion is that p of x is a possible representation of this graph. So you have two possibilities, and you have to make sure you look at your directions. It did say explain, so I would expect you to tell me yes or no and then explain why, or at least show me the information I showed you here. This concludes your notes for today.